So what do we mean by that? Well, if we take this data here, which is from a review paper published in 2004 by Saunders, what we've got here is we've got running speeds. Now I want you to ignore the max data for the moment. It's a little bit of red herring. And I want you to just focus on fundamentally these submaximal speeds. Why are they submaximal? Because they're below VO2 max. And for both of these individuals, subject 1 and subject 2, we've got the oxygen cost at these three different speeds, 14, 16 and 18 kilometers an hour. And what we can see is, well, two things which are very important. One, we can see actually which athlete is more economical, and two, we can see a fundamental concept of exercise physiology, which is the linearity between oxygen consumption and work rate. And I mean, subject 2 is perfectly linear. Subject 1 is not quite, but one could put a line of best fit through that, would be almost perfect. But that notwithstanding, who's more economical? Well, if we go back to the definition from Barnes and Kidling, and what you see here is the steady state oxygen consumption at a given running velocity is referred to as running economy. So if you are consuming less oxygen at the same absolute exercise intensity, then you're more economical. So subject 1 across these speeds here is far more economical than subject 2, because subject 2 is using around about 10 mils per kilogram per minute more oxygen at each of these relative exercise intensities. So we see quite simply, quite diagnostically, don't we? We can see the economy profile of these two athletes. Now, if we delve a bit further into this is a paper published a while back now, and this came from Veronique Billet's group. But it's quite nice because it just gives us an idea of the factors that govern endurance performance. And it's not necessarily about the economy per se, but you'll see where that comes in a moment. But we've got a range of data sets here. We've got our males and females, and we've got what they call top class and then high level. These are our elite athletes. And we've got a range of things. So you can see here, this is the marathon time in these guys. There's not an enormous difference in the kilometers per hour between these two groups. And then these are their velocities at different race distances and VO2 max, and then what they call the fractional utilization. So this is the percentage, the fractional utilization, this is the percentage of VO2 max which they can operate at. And then the cost of running is their measure of economy. And notice the units are slightly different. The units here are being expressed as mils per kilogram per kilometre. And in fact, if we zoom that in a little bit, and we just deal with the males, the same applies to the females. So here we've got our top class runners. So these are the individuals that are running about half a kilometre an hour faster than these high level runners. They've got a higher VO2 max, actually quite significantly higher, but that interestingly is probably not the key factor to these. But interestingly, when we look at the cost of running, they're actually less economical than these guys. How do we know? Well, the key thing is the number. The lower that number, the more economical that individual is. And that's despite the fact, when we look at things like the velocity at 3,000 meters, they're almost identical. The VO2 max does seem to be differentiating the two groups, but these guys are actually more economical. And the reason these guys can get away with being less economical and yet still have a faster time is because their VO2 max is higher. And that's really where this session will conclude when we start to address the notion of the velocity at VO2 max. But it just gives us an idea about the way in which these parameters interact with one another to govern endurance performance. So if we come a bit further forward, this is from Jack Daniels, and this was published in the early 90s. But this is, again, really nice data, because what we've got here is males and females. And again, ignore the extrapolations. So what they've done is they've taken these points here as VO2 max and extrapolated back to the x-axis. But just look at the submaximal data between the two population groups. And so what you can see here is that our females are less economical than our males. So at the same running, they call them running velocities, but they're the same running speeds, it's probably treadmill based. You can see there's quite a significant difference between the two groups. Now, the why is a different question, but the why is obviously due to underlying physiological differences between males and females in terms of heart size, the size of the left ventricular mass, hemoglobin concentration, the amount of free fat and adipose tissue that is being carried in females compared to males. All of those will contribute to a higher oxygen cost, but we can see from the data that quite clear distinction between these two groups. If we then come into this data set, so this is kind of quite interesting. So this is where we've got some data. This is from Dan Morgan's group back in the 90s. And what they've done here is they've done a simple correlational analysis. And they've taken the oxygen cost in mils per kilogram per minute at a constant running speed. So they've looked at this speed, which is 268 meters per minute. So in other words, that they've taken all their athletes, they've had them on a treadmill, fixed running velocity, measured the VO2 response. And what they discovered is that there's this really nice linear relationship between running economy and 10K race time. That is, the lower the oxygen cost, that is, the more economical they are, the faster the race time. And as we start to become less economical, shown by a rising VO2, so they're using more oxygen because they need to resynthesize and produce more energy for the muscle to do work, the slower the running time that we see here. So this is a really nice information for us, or piece of information for us, because it really reinforces the notion of the currency of economy to endurance performance. And this is a paper from my group, actually published in 2017, and we took a large group of recreational marathon runners. I think it was about 87 or might have even been 92. Significant number of marathon runners that we tested. And these guys were running from groups of 2.5 to 3 hours, 3 to 3.5, 3.5 to 4, and 4 to 4.5, and then greater than 4.5 hours for the marathon. And what we've done is represented their economies. These are average scores for the group. Now, there could have been, and there should have been error bars, shouldn't there? But of course, there had been so much overlap, that's why there's no error bars shown. But what I want you to look at is this group here, so our X's here, this is our fastest running group. So these are the 2.5 hours to 3 hour marathon runners. And so if we compare those to this group up here, these are our slowest group. These are the longer than 4.5 hours group. This is our second fastest group, so this is our 3 to 3.5 hour group, and then we've got this slight overlap between these two groups here. But if we just look at these two groups compared to this group, and just focus on really the treadmill speeds from 10 to 13 kilometers an hour, that's where they've all got agreement. Look at the difference. In the fastest marathon runners, they're actually operating at around about 57% VO2 max, 60% VO2 max, probably about 62, close to 70% VO2 max. Now, if you compare those to the slowest marathon group, the slowest marathon group are operating at the slowest speed at a higher percentage VO2 max than the fastest marathon group were at their fastest comparable speed. So this really lends to itself actually this notion of economy being really important. Now we've expressed the economy slightly different here, so rather than expressing it as mils per kilogram per minute, we've simply just expressed it as the percentage of VO2 max. So it's a same principle, and you can see the linearity between VO2 and workload, but you can see that discrepancy between faster runners and slower runners, or faster athletes and slower athletes. And this is why economy is so fundamentally important to endurance performance. It's a real powerful tool for discriminating between faster and slower runners. Now, earlier on we had the data from BA's group where she referred to the notion of the cost of running. And the cost of running is just a way of representing this slightly different. And there's different ways of doing this. Di Prampero and colleagues talked about the cost of running being the VO2, the oxygen cost at a given workload, minus the resting VO2. But this group here have done it slightly differently. They're taking the cost of running, but notice what they've done with the data. It's mils per kilogram to the minus 0.75 per per min. And what they've done is this is what's called scaling the data. It allows us to compare. It's a bit like comparing apples and pears. We scale it. And when the data is scaled, what you'll see now in this data set is that the females are more economical than the males. And when you scale the data, what you're doing is you're taking into account body proportionality. And so suddenly, this takes out of the equation what we mentioned earlier on when we were looking at the data from Daniels and Daniels, which was, we talked about the idea there that body composition would play a part. You know, females carrying perhaps excess body fat, carrying fat in regions that males do not have to, on the mammary glands, for example. When we scale, it fundamentally allows us to adjust for that. And when we adjust for that, you can see that the females are actually now more economical than the males. So it really does tell us how important body composition is, that, you know, if we're carrying excess body fat, we've got to move that. It's a dead weight that costs us energy, which increases the VO2 response.